All right, joining me now is Dr. Terry Bates. Terry is the Senior Research Associate at Cornell University and the Director of the Cornell Lake Erie Research and Extension Lab for Cornell AgriTech. That's a big mouthful. So, hey, Terry, thanks for joining me again on the podcast.
Hey, Fritz. Always good to be on the show.
Yeah, absolutely. And, it's been almost 3 years since you were last on the podcast with me. So our audience may need a little bit of reintroduction. I've known you since I was a undergrad back at Penn State. You're also a Penn State graduate. In fact,
Yep.
you mentioned when we were chatting before the recording here that you actually worked on phosphorus for your PhD at Penn State with
I did.
Dr. Jonathan Lynch, who was
Yes.
my plant nutrition professor,
Yep.
amazing plant nutrition professor and researcher. So if you want to bring that into the intro at all about yourself, great. But just briefly tell us about yourself, how you got interested in viticulture, plant biology, and what you're focusing on these days.
Yeah. So as you mentioned, I was a grad student at Penn State in Jonathan Lynch's plant nutrition lab. All my research was on Arabidopsis, which has really not much in common with grapes. But it was all on root biology and phosphorus nutrition. And in that case, it was how Arabidopsis would grow longer root hairs to get more phosphorus because it's a non-mycorrhizal plant. And I'm sure we will talk about that.
So Arabidopsis. So why is the opsis rabid? Maybe you should explain what Arabidopsis.
Yeah. So Arabidopsis is like the little white mouse for the plant industry. So it was the first plant where they mapped the entire genome, and then they would create mutants, seed lines from Arabidopsis. So I was able to take advantage of mutant seed lines that, either didn't have root hairs or had different root architecture. And we could look at how root architecture and say investment in growing root hairs, how that impacted phosphorus uptake.
Oh, cool.
Yeah. So it was just, it's just a tool.
You translate that into how plants in the wild, if you will, would actually function.
Right. Yep.
Yeah. Okay, cool. Okay.
Yeah. So after that, right out of Penn State, I got the job with Cornell working in viticulture. And I think a lot of people were scratching their head on how I could go from Arabidopsis to Concord grapevines in Western New York. But at the time, the industry was looking for someone to work on root biology and nutrition. So I got the job. And I've been here 27 years. So it's been a lot of different things, everything related to production in the Concord industry. So first we worked on a lot of nutrition work, trying to basically grow more grapes, right? Bigger, healthier vines, grow more grapes. Then the focus switched to growing higher quality grapes. So we did a lot of work with crop load management, pruning levels, training, light interception, all this traditional viticulture type stuff. And then the focus moved to reducing production costs. So we got into this whole world of vineyard mechanization and trying to marry our viticulture concepts with the machine applications in the field. And for about the last 10 years, we've been heavy into production efficiency or precision viticulture. So I think we've talked about this before on your show about using spatial data from sensors to understand what that variation is in the field and being able to respond our management practices to that.
When do the roots tend to grow the most and produce these feeder roots? Because I think if we understand that, am I not correct in thinking that we can understand better when to apply certain nutrients to time it with that best uptake?
Yeah.
Is there anything we know about
So
that?
there's a spring flush of roots, and that's working off of reserves from last year. So you'll get, so in the springtime, the vine uses reserves to build a canopy and to build new roots so that it can do photosynthesis and take up water and nutrients. And then there seems to be a lag in root growth just after bloom. So when the canopy is really growing hard and the fruit's starting to set, at least in New York, Concord, this is where all my information comes from. There seems to always be a little lag in new root growth at that time. But then in the middle of the season, when the canopy takes over and we're getting new photosynthesis, then we're starting to get most of our assimilation of mineral nutrients are in that middle part of the season.
Okay. So you went down to 5.2 as kind of like your bottoming out point for, things like aluminum becoming available. And then I believe that the problem is aluminum is toxic to root tips growth, right? So it
Yeah,
almost
so
like
that's
goes
the
down.
second. Yeah. So, I mean, the main thing that happens is it ties up phosphorus. So that's a
Okay.
problem. But yeah, if you have too much aluminum, and I think it's, I don't know, the number is like 200 parts per million or something like that in the soil of aluminum, it will actually interact with the genetic material in the root tip and it'll stunt root growth, which only lessens your root absorptive surface area and will lessen the amount of not just phosphorus, but any other nutrient that it can uptake.
Right, got it. But phosphorus in particular. So okay, so a grower wants to fix their soil pH because it's too low. What are you recommending typically?
Just use lime. I use- so yeah. So find the cheapest lime source you can for what we call a calcium carbonate equivalent. And our biggest thing is that we don't want to put down too much all at once. Like you may send in a soil test. It may say your pH is 5.5 and you want to be at 6.5. And it says, oh, you want to put down 4 tons per acre of lime in an established vineyard is a bad thing. So we always say no more than 2 tons per acre per year for lime applications.
In an
An
established.
established vineyard.
Okay.
If you're going to go in and plant a vineyard, if it says apply 6 tons per acre of lime to get the pH where you want, go ahead and do that. And what we usually do is we put down half the lime and deep plow it in as much as we can, and then put the other half down and disc it in, and then plant the vineyard on top of that. In an established vineyard, so that lime is calcium and magnesium carbonate. The carbonate is the business end of that thing. That's what's changing the soil pH. Calcium and magnesium they just end up being cations. So like another nutrient, and those will flow through the soil profile. And in our situation, so we have Concord vineyards and we're growing big vines and big crop sizes that require a lot of potassium. And if we put on too much lime at once, we get too much calcium and magnesium that outcompete the potassium, and we end up with potassium deficiency. So if we want to adjust the soil pH up in an established vineyard, we do it a little at a time. 2 tons per acre of lime per year until we just keep adjusting up until we get to the pH that we want.